Okay, so related exercise, we end the part 2 of sets. So now we're going to part 3, which is talking about Venn diagrams. So there we'll learn how to draw a Venn diagram having one set, having two sets, or having three sets, and then solving word problems, like real life problems using Venn diagrams. Alright, so now we're doing third part of Introduction to Sex, which is Venn diagram. The third and the most crucial part, because that is the part in which you most likely see the exam questions coming. You most likely come in this part. So we're going to see Venn diagrams. First, the introduction to Venn diagrams. Then, important formula I used to know. Then, one set Venn diagram, meaning Venn diagram created with just one set. Then, two set Venn diagrams with the cases. Then, three sets Venn diagrams, and in each of the sets, you are going to solve questions concerning the sets. We're going to do examples and word problems, and then we'll do general exercises in all of the parts. So, on starting, we click on one introduction to Venn diagrams. So, what is a Venn diagram? A Venn diagram is a graphical representation, like a visual representation of the relationship between sets, between one or two or three, or any number, two or more sets, one or more sets. So, a Venn diagram is made up of few parts. I think, okay, maybe just take the parts. Belum sebentar dari roti akan white Tottenham. This route to be right here. The part of a Venn diagram. So, for a pass, we have the rectangle. It could be a square if you want. So what does it do? It shows anti-zeta or zeta, which is the universal set. So it englobes all of what you're talking about. If you're talking about the days of a week, it will be inside it is the whole set. Well, before drawing a Venn diagram, we're going to enumerate all the parts. So how do the rectangle? We have circles, which represent individual sets. So a set, your set A, or B, or C, can be represented by a circle in Venn diagram. It's always represented by a circle. So if you have a set A of people in form 2, you represent two of this. You remember it as A, and then you write the number of people in form 2 here. Or if you don't have the number, you write the name of the people. It could be John, it could be Doe, John Doe. If you have two people in form 2, you write your set A. Inside the circle, you write the element of the set. So yeah, on the third part of the Venn diagram, we have the overlapping. How does it show? It shows, we call it overlapping or intersection. So it shows when the circles, it shows the intersection, as you said already. it shows the number which are common to both sets or to any sets. For example, here we have the overlapping. Here it's called the overlapping or the intersection. If you put A here, if you put 2 here, which 2 is common to set A and set B. This is the section we're not okay. Here it shows A intersection B. So let me just say it's on the intersection. When you say intersection, you already know what it is. Shows A intersection B or any set intersection, any other set. It's not always for 2 sets. It could be for 3 sets. For example, you have one set here, one set here, one set there. This is an intersection between the 3 sets A, B, and C. This is A, this is B, this is C. This point here is the intersection between these 3 sets. This point here is the intersection between B and C. This point here is the intersection between A and B, and here is between A and C. And then we have the regions. So what do the regions show? It shows a specific number of people or it shows which specific element is to only that set. Like if you have something like this, all of this. Is the region D. Just be this will be. So this shows which elements are specific only today. So elements here will be specific just today. So here elements here will be specific just to B. So if we say A is the number of people that play football, inside this region B, the number of people that play only football, nothing else. So here you not find people that play football and another sport. So here it shows elements specific to a set. So here is those elements specific to a set. So now let's represent, let's see how it looks like physically. Physically, it's going to look like, okay, let me just draw let me increase the 2 rings. Simple isn't quite right. Okay, let's consider that second. So if this is our set A and this is our set B, this will be our universal set antecedent. So this is a region. Let me name all the parts. This is the region of set A. Here will be set B. Only. Here we write the only. Here is A intersection B. And here you can have anything that is not A. Anything that is inside A and B. A and V verb is not inside A and V, but inside epsilon. You can also inside V and A. You can represent it as zeta minus A union V. Means everything that is not in this set, everything that is not inside A and V and not inside also A intersection B. Outside of the two sets, but inside of the whole box, inside the whole universal set or anticipa. So if I for the introduction. So we see that here our rectangle represents our antitheta, which is the universal set. Here the circles we represent individual sets. So all these circles represent, if anything is inside this circle, you represent the set A, everything that is inside the set A. Even if it is inside here, it's also inside the set A. Just that it belongs to set A and also to another set B. So the overlapping of the intersection shows A intersection V that here is the overlapping. It shows A intersection V. And the regions, these are the regions here. This part here, like this part here, they show set A only and set B only. Element of a set that specific just better. It shows elements specific to a set. So here, you show me elements specific to set A. And here, you're going to show me elements specific to set B. Alright. So let's go down to a one set Venn diagrams. Let's try to set now. Now that you have a clue of what our set are gonna look like, can dive into it now. And there, guy. So we are at 2.3.2. Oh, at 3.2 we have important formulae first. I'm going to talk about important formulae. Right into comments. So these are the formulae you use. So if it looks difficult, if the questions look difficult, you're going to rely on the formula. But if it is easy, you can use your logic and solve it. It will still be correct. So on the formula you have the union formula. The first one So the first formula says number of A union B is equal to the number of A plus the number of B minus the number of A intersection B. So for example, if they ask you that, okay, you got a set like this. We got a set like this. Okay. For example, I'm not reading those sets. They tell you that 15 people play basketball and 10 people play football. And there are 20 people in total. So there are 20 people in total, that 2 people that play basketball and 10 people play football. So all is A and B. A union B, if you say it is just because in this our case, the number of people that play basketball is equal to 15. The number of people that play football is equal to 10. In the article A and B, how many people play basketball and football? If you add these two, 15 plus 10, you're going to have 25. 25 is already more than the number of people in total. So if you have a total of 20 people, you can have 25 people as a total number of people that play basketball and football. So the answer for A union B, we're going to have that 20 people in football, that 20 people in total. Okay, they'll ask you for A intersection B. Because they already gave you A and B, they always told you that 20 people are there in total. So if they ask you to find A intersection B, how are you going to do it? A intersection B is the number of people that play football and also play basketball. How are you going to do it? You're going to have number of A and B, in this case number of A, in this case number of B and X will be equal to number of B plus number of X minus number of B intersection X. How is that going to be? Number of B and X is 20. 20 is equal to number of B is 16 plus number of F 10 minus number of B intersection F. We don't know this. So to find this, we make this subject of formula. If we bring this one behind here, it is going to be N of B intersection F is equal to you bring this one here behind, it becomes negative. But before writing, you write this and this. 15 plus 10 minus your 20. And it's going to be what? 15% is 25. 25 minus 20 is 5. So what does this mean? It means there's 5 people that play both basketball and football. 5 of them play both basketball and football. That's how you find A intersection B. And if you test the formula, if you use this 5 and test the formula, you'll see that A union B is equal to 20 is equal to NK. Let's check. Let's test the formula. In our case, this is equal to 20, right? 20 is equal to NB 15 plus NF 10. That goes for this plus this. Minus none this is our N of A intersection B is 5. Is that correct? 20 is equal to 15 plus 25 minus 5, 30. Meaning it is correct, this formula is correct. So you can go to the next formula. The next formula says they ask for N of A only. It is equal to N of A minus N of A intersection B. And it's called 2 sets. This called 2 sets formula. I should be writing it there instead. I have N of A union B equal N of A plus N of B minus N of A intersection B. Now I have N of D on D equal
n of A minus n of A intersection B.
We're going to see how these formulas work when we start solving. So the third one says n of B on A is
N of B minus n of A intersection D.
let me just write it.
N of B only equal to n of B minus n of A intersection B.
Now the fourth one says neither. Like to know which one, we know what numbers, what elements are neither in A or B. Which formula are we going to use it? Which formula are we going to use finally? So we have
N of B neither
is equal to
n of antizeta minus n of A union B.
you see, as it does say it, antitheta minus A union B is going to give you all of what is not in the sets, or it's out of the set. So number of all of what is neither in B and B will be number of every D minus this. You see, if you take every D here and you remove A and you remove all of this, you'll be left with what is outside. So that is it. You take everything minus A million V. You'll be left with just what is outside. So the fifth formula says number of A prime
is equal to number of antizeta minus.
So number of A prime is equal to number of antizeta minus number of A. So number of A prime, if you want to know all of what is not in A prime, or in all of what is not in A, right? This is A. If you want to know all of what is not inside all of this A, we're going to take zeta. In that case, it is everything minus A. So we are going to take everything like this.
Everything, and you remove A. We're going to remove that A.
Then similarly, you remove A from this everything, you'll be left with everything that is not in A. So that's the formula what the same. We have left 1, 2, 3, 4, 5. That is formula. The second one and the last one, it says at least. So when they ask you for which number or how many people or what is the number of elements, we do at the least which is touching at this A and B. What formula are you going to use?
So the number of at least is equal to the number of A and B.
So to find the number of people that have as that number of elements that have at least at A or B, I want to do number of A and B. So to find A and B, this is here. Number of A plus number of B minus number of A intersection B. So that is it for the formulas that we're going to use. Let me just write this. I have done you. Okay, so we're done with the formulas. Now let's go to 3.3 wanted diagrams. Let's go to wanted diagram. We are going to see what a wanted diagram is, and we're going to solve some problems regarding wanted diagrams. Wanted Venn diagrams. So what is a wanted Venn diagram? It is a Venn diagram as its name implies. It is a Venn diagram which has just one test. So what is it going to look like? I'm going to have a square or rectangle, and we have one certain side of quarter A, and also the we have our antithetical or universal set. So this is what it's going to look like. So under the two parts, around the part inside the circle, and the part outside of the circle. So let's take an example. Okay, let's take an example. Example, yeah, our antecedent, the set is given us 1, 2, 3, 4, 5, 6, 7, 8. And we have our set A 1, 3, 5, 7. So how do you represent this on a Venn diagram? Is it going to be a one-set Venn diagram or a two-set Venn diagram, or how are we to represent this? So when you see just this and this, you know it is a one-set Venn diagram because there are just two sets, which is the universal set and the main set. So how do you represent this on a Venn diagram? So firstly, draw a box. You must not first, it's not even recommended to draw a box. Firstly, you draw the set. So you draw a circle. We label it with the name of the circle A, the name of a set A. You write everything that's inside. 1. Well, before writing things inside, finish drawing. When they say there's no more on any other set, we have our epsilon there. So we draw the closest. And we write our epsilon here. So you will write your epsilon here, your zeta, sorry. You always write your zeta here and your A outside of it. So what are the elements in A? You have 1, you have 3, you have 5, and you have 7. So here you put the elements that are in A. Those elements they are also in antitheta. 1, 3, 5, and 7. Now outside of it, you have to put elements that are in antitheta which shall not be A. Because you have already used this element, you have already used this. Which means you have already used this, and this. But you are left with some elements. All of the elements inside this are supposed to enter the Venn diagram. What are the elements you plate? This 2, you write it. This 4, you write it. This 6, you write it. And this K, you write. You can write anywhere. You write anywhere. You can write here. As far as it is outside in the circle and each side, the rectangle of the antecedent is fine. So you have to make sure that all of the elements in all of the sets are written. here. All of the elements here should be written here. So you have another number, it should be written inside this set. Yeah, the one is telling you where it's supposed to be written. If another number is the, if you have another number here, like 8. You have another number in like 8. You have to know where are you going to write it. I'm going to write the 8 inside A because the number is in A. Consequently, you are going to remove it from here. Why are you going to remove it from outside? Because that 8 is going to be in A and not outside. Outside there are numbers that are not found in there. So if the number, if that number is found in A, then it is not supposed to be outside. It's supposed to be in A. It can be outside like this 4 when a number is not found in K. This 4 is outside because there is no 4 here. That's why it's outside. So you will ask me, why don't you write 10, 11, 12, 50, 100, 1000? They're not also in here. Well, you're supposed to write only the numbers which are in your antecedent. I'm supposed to stop at the numbers which are in your antecedent. If they remain outside, if it ends at 8, like it is ending here at 8, you don't write 9, you don't write 10 because your universal set ends at 8. So that is it for the first example. So now, they ask you for some things here. You ask you for what is the number of elements in A? N of A. That's what they can ask you. What N of A going to be 1, 2, 3, 4, 5. N of B. N of they can also ask you for N of A friend. N of A prime is the number of elements which are not in A. What is it going to be? 1, 2, 3. You write a 3 there. So you count the elements which are looking A. You write it. Then of A prime is equal to 3. And you can have N of antecedent. So N of antecedent means the number of elements which are in a whole universal set. Like all this antecedent means the number of elements everywhere. So when you count, what is it going to give you? 1, 2, 3, 4, 5, 6, 7, 8. 8. So in that case, you are counting all of the elements which are everywhere, found everywhere. So here's that'll be all for the first example. Let's go to the next example. For the next example, we have example 2. We have our antecedent as vowels and first part letters too. So here is the second way of describing sets, which is a, how you call it, a descriptive method. So this is the descriptive method of describing a set. You see here, you are not giving you exactly the members of the set. You have to derive it yourself. So what I'm giving you is a description of the set. Now, you have another set A called vowels. So you have two sets. Antecedent, which is vowels, and the first five letters, and you have an A which is shown vowels. So how do you represent this? You first have to find the person that you have to do when you have this state in this receipt method. You have first to put all of the sets in the listing method so that you can see actually with your eyes what are the members of the set. So here in Epsilon, what we have in zeta, what do we have? vowels and the first five letters. So what are the vowels? Yeah,
A, E, I,
O, and U. So I'm writing the vowels, and I said also first five letters. First five letters we have
A, B, C, D, and E. We write A. Do we write A here?
no. Since we already have A, we don't write A two times. A is already an element. So we write about B.
We already have B, no, to write D. Write C, write D, and the fifth one is E.
Is E here? Yes. We already have that E. So you don't write E time. Write one time.
You do same for A. A said just vowels. So the vowels are A, T, I, O, U.
So these are the vowels. And these are the vowels of the first five letters. So if they ask to represent this in a Venn diagram, how do you do?
So you draw, well, draw a circle. Then you draw a square. Yeah.
Yeah, antizeta and A. Actually, your favorite draw a square first, or a rectangle first. Because you might draw a circle and then there's no more space to put the rectangle. Whereas if you draw the rectangle first, you will know how to manage the space in order to insert your sets. Okay, so
All of what is in A, you write there in A. So you have A, E, I, O, U. Correct in any order
as far as the missing P is correct. Now, you're already written A, E, I, O, U. But there are some other letters. If you remove A, E, I, O, and U, you will see that there is still B, C, and T. So since B, C, and T are not in A, put them outside. They are in antizeta. So you put them inside antizeta but outside of K. So it is B, C, D, right? B, C, D. And I thought very acid.
So this region is A. This region is A prime. And all of this is
Zeta. So what is the number of elements in A here? What is it? 1, 2, 3, 4, 5. If they ask you for a number of elements in A prime, what is it going to be? Look for every element that is not in A. B, C, and D are not in A, so they are in A prime.
so right here 3. If they ask you for the set A prime,
They are going to say it is equal to B, C, and D. Here is a set A prime. If they ask you for the number of elements in A prime, just write the number of elements in A prime. How many elements are here? 1, 2, 3. Just write here 3. So you should get the express between the two. If they ask for this, you write the number. If they ask for just this, you write the elements of the set. Okay, so the last one is
the number of elements in anti-zeta.
what is the number of elements in anti-zeta? You just count all the elements in the whole Venn diagram. So you have 1, 2, 3, 4, 5, 6, 7, 8. Write it again. So you should make sure that you don't have the same values 2 times. Because when the same vowels, you have A, E, I, O, U. When you say first 5 letters, you still have A and E, but you don't write it twice. If you have already written it, you don't write it again, you go to the next. Yeah, on a view here, Venn diagram.
That is all. Let's now go to 2 set Venn diagrams.
So that is 3